all, I am Shilujas and I welcome you all to today's session. So here we are going to discuss about CUET 2022 question paper on statistics. So you guys already know how important it is, along with learning the syllabus, how important it is to learn the question papers, to the previous year question papers. It will help to understand the patterns of the question paper and the important parts of the syllabus. So without any delay, we'll look into the questions and discuss about the answers. So the first question, 4 persons A, B, C and D take turns in the sequence A, B, C, D, etc. in rolling a fair die. Out of these 4 persons, the one who rolls a 6 for the first time will win the game. Then the probability that D wins is. So here the question says that there are 4 persons A, B, C, D and they are going to roll a die. So a die is having 6 sides. So we can number it from 1, 2, 3, etc. to 6. So out of these 4%, the one who rolls a 6 for the first time is going to win the game. So when A is going to roll the die, if the die can show the numbers from 1 to 6. So if 6 is going to show, then A is going to win. But in the question, we have to see the probability that D wins. So probability D wins means A, B and C should not get 6, but D want to get 6. So we can see that the probability of getting a 6 while rolling a die will be equal to 1 by 6. So since 6 numbers are there and number 6 is one among them, so the chance will be 1 by 6. So obviously probability of not getting a 6 will be not getting a 6. So this will be 1 minus 1 by 6, or simply we can say 1, 2, 3, 4, 5. 5 numbers are there other than 6 and its chance will be 5 by 6. So we have A, B, C, D. This will be the order in which they are going to roll the die. So if A is not going to get a 6 means the probability will be 5 by 6. If B is not going to get, probability will be 5 by 6. Similarly for C it will be 5 by 6 and D we have to get that D wins. That is D is going to get a 6 while rolling the die. So it will be 1 by 6. So if we want to get the probability that D is going to win, the total probability in the sequence, so it will be 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6. So this will be the answer in the first sequence. So similarly, here we can see that A, B, C, D, again A, B, C, D is coming. If A, B, C, D in the first trial, all the 4 is not getting a 6 means we are going to try that again. So here it will be 5 by 6, 5 by 6, 5 by 6, 5 by 6. Again we are going to start another one, 5 by 6, 5 by 6, 5 by 6 and another 1 by 6. So this continues until we get a 6 while rolling the die for D. So this is going to continue. Here we can see that this will be 5 by 6 cube into 1 by 6. In the next step it will be, all this will be 5 by 6. So 5 by 6 raised to 4 into 5 by 6 cube into 1 by 6. So this is going to continue until we are going to get the a 6 while rolling the die for D, and the final answer will be, so finally we will get some geometric series, that is 5 by 6 raised to 3 into 5 by 6 raised to 7 into etc. into 5 by 6 raised to something into 1 by 6 we are going to getting. So that will be a geometric series, and the sum of geometric series we can see as S is equal to A by 1 minus 6. So A will be the first term and R will be the ratio. So A is nothing but 5 by 6 into 1 by 6. This will be the first term and R will be the ratio, which will be equal to, and that R will be equal to 5 by 6 raised to 4. So we can substitute the values of A and R in this equation, that is 5 by 6 raised to 3 into 1 by 6 divided by 1 minus 5 by 6 raised to 4, and the final answer we are going to get while solving this will be 125 divided by 671. That is option number 2 is the right answer. The next question, In the context of right skewed probability density function, which of the following is correct? So we have already learned what is skewness and how it is going to affect the mean, median and mode. Here we can directly find the answer, that is mean will be greater, median will be in the second position and mode will be the third. That is the option 2 is the right answer. Mean greater than, median greater than mode. Next question is a frequency curve is given, that is the frequency curve of a data is given below. The mean, median and mode of the data respectively, that is a frequency curve is given. So from that we can get the values. Observations are 1, 3, 5, 7 and 9 and the frequencies are 3, 5, 4, 2, 1. So simply we can write X and F. If we are drawing a table, we will get X will be 1, 3, 5, 7 and 9 and the frequencies will be 3, 5, 4, 2, 1. So we have seen equations for separately for raw data and frequency data on how to find the mean, median and mode. So let's take an instance for mean. Mean is actually summation x by n, but for a frequency data it will be equal to summation fx divided by summation f. So here fx will be 1 into 3. We can find another column. Fx is equal to 1 into 3, 3, 3 into 5, 15, 5 into 4, 20, 7 into 2, 14, 1 into 9, 9. So we are going to add these and then divided by summation f and we are going to get 4.066. So similarly we can find the median and mode. Mode directly from the graph only we can see that the highest frequency is 5. So the corresponding observation will be the mode, that is 3. So from that we similarly we can find the median also using the equation and the answer will be option 2. That is mean will be 4.066, median will be 3 and mode will be 3. So option number 2 is the right answer. Let A and B be two events with the probability of A is equal to 0.5, probability of B is equal to 0.3 and probability of A intersection B complement is equal to 0.3. Then probability of B given A union B complement is equal to. So given question is about a conditional probability, that is we have to find out probability of B given A union B complement. So we know the expansion of conditional probability as probability of B intersection A union B complement divided by probability of A union B complement. So probability of B is already given and A intersection B complement is given. So from that we have to find out the probability of A union B complement. So simply taking the addition theorem, we can see that probability of A union B complement is equal to probability of A plus probability of B complement minus probability of A intersection B complement. So probability of B is given already. So probability of B complement will be equal to 1 minus probability of B, which will be equal to 1 minus 0.3 is equal to 0.7. Probability of A is equal to 0.5. So we have the values for probability of A, probability of B complement and A intersection B complement. From that we can find out probability of A union B complement and substitute in this equation, that is probability of B given A complement. So we are going to get the final answer as option number 1, that is 2 by 9 will be the answer for probability of B given A union B complement. If probability of A is equal to X and probability of B is equal to Y, both not equal to 0, then probability of B given A belongs to. So we have to find the interval in which probability of B given A is going to belong. So here it is given as probability of A is equal to X and B is equal to Y. So we can see that probability of both will be equal to 1. So X plus Y is equal to 1 we can write. So probability of B belongs to A belongs to. That is, we have to see the interval. Since it is a probability, it is of some values between 0 and 1. So before discussing the steps, I will show which is the correct answer. Option 2 will be the correct answer and we will see. We have to get 0 and 1. Simply taking the numerator, we can see that if X plus Y is equal to 1, X plus Y minus 1 will be equal to 0 and X plus Y equal to 1. So we have got the range between 0 and 1. So option 2 will be the right answer. Next question, the data collected from the National Census Survey report is. So this is a direct question. National Census Survey report means they will be collecting the data through census survey. So that is, they are collecting the primary data. If we are collecting the data from the National Census Survey means we are collecting the data which is already collected. So the answer will be secondary. So It is the secondary data that we are going to collect from the National Census Survey. Next question. An urn contains 4 white and 6 black balls, and urn B contains 6 white and 4 black balls. An urn is selected at random and a ball is drawn at random from the selected urn. If the drawn ball is white, what is the probability that urn A was selected? So, we can see that, let us take event A as urn A is selected, and event B as urn B is selected. And we will define a third event, that is W, which is getting a white ball. White ball is selected. So here the question is that we have to find out, if the drawn ball is white, what is the probability that urn A is selected? So probability of selecting urn A given that the ball is white. So it is a conditional probability that the selected urn is A given that white ball is selected. So using Bayes' theorem we can prove this. This is a question using Bayes' theorem. We have already learned the equation for finding out the Bayes' theorem. So here we can split this as probability of A given W will be probability of W given A into probability of A divided by probability of W. So we have to find out what are these terms and substitute in this, and directly we will get the answer. So probability of A means probability of selecting urn A. So since there are only two urns, urn A and urn B, selecting one among them will be 1 by 2. So probability of A is equal to probability of B will be equal to 1 by 2. Now next one is probability of selecting a white ball. So probability of W we can see. So there are total 4 plus 6 plus 4 plus 6, that is 20 balls are there. Total will be 20 balls. Among that, choosing a white ball. So total number of white balls will be 4 white and 6 white will be 10. So this is also 1 by 2. Probability of W is equal to 1 by 2. So we got this term and probability of W. Now we have to find out probability of W given A. That is choosing a white ball from the urn A. That will be equal to probability of W given A is equal to total number of balls in urn A is divided by 10, and choosing a white ball among them will be 4. So it will be 4 by 10. If we want, we can simplify that. So substituting these values for probability of W given A, probability of A and probability of W, we are going to get the answer for probability of A given W, which is equal to 4 by 10 into 1 by 2 divided by 1 by 2, which is equal to 0.4. That is option 1 is the right answer. 0.4. Next question. Let x1, x2, etc. xn be independent and identically distributed Bernoulli random variable with parameter p, where 0 less than p less than 1. Then expectation of minimum of x1, x2, etc. xn is. So this question we are going to split as, given that it is an IID Bernoulli random variable. So for Bernoulli random variable, we know that the distribution takes value 1 with probability p and value 0 with probability 1 minus p. So this is the Bernoulli random variable. So let us take represent some m is equal to minimum of x1, x2, xn. So we have to find out m of 0 and m of 1. That is, when we only for Bernoulli random variable is only going to take two values, which will be 1 and 0. So we are going to find out the probability of this minimum value when it is going to take two values, that is 0 and 1. Since it is a Bernoulli random variable, we will find out probability of m equal to 0 separately and probability of m equal to 1 separately. So we know that minimum of x1, x2, etc. xn is going to take a 0 value only when all the values, that is all the x's is having zeros. So we can simply write it as probability of x1 is equal to 0 into probability of x2 equal to 0 into etc. into probability of xn equal to 0, which will be 1 minus p to the power n. That is 1 minus p is the value which is going to take when the value is 0. So here we are going to we are multiplying x1, x2, etc. till xn, that is n times. So the probability of p such that minimum value is 0 will be 1 minus p raised to n. Now probability of m equal to 1. Here it becomes 1 when either any of the x1 or xi is going to take 1. So we cannot substitute it as like this, that is probability of x1 equal to 1, x2 equal to 1. We cannot say like that. Simply we can subtract it from 1, that is 1 minus p raised to n. This will be the probability of m equal to 1. Now we have to find out the expectation of m, which is equal to 1 into probability of m equal to 1 plus 0 into probability of m equal to 0. This will be equal to 1 minus p raised to n plus 0, which will be equal to 1 minus p raised to n. That is the third option is the right answer for given question. Now we have the question, if the correlation coefficient between x and y is 0.3, then the correlation between 2x plus 3 and 4 minus 3y is. So, the correlation between x and y, rho xy is given as 0.3. Now we have to find out rho 2x plus y, 4 minus 3y is equal to. This is the value that we have to find out. So, we have a standard equation that rho ax plus b, cx plus d is equal to a into c into rho xy divided by sigma x plus b into sigma cx plus d. We are going to substitute in this equation, that is we have a is equal to 2, b is equal to 3, c is equal to 4, c is equal to minus 3 and d is equal to 4. So we can substitute these equations. Before that we have a value, c value, rho xy value, but we don't have sigma x plus b and sigma cx plus d. For finding out these also we have direct equations. That is, if ax plus b is a linear transformation, we have the standard deviation of this linear transformation as modulus of a. So, here 2x plus 3 we have values 2x plus 3 and 4 minus 3y. So, its standard deviation will be modulus of 2, which will be equal to 2. And for the second one, standard deviation will be modulus of minus 3, which will be equal to 3. So, we got all the values. So, we are going to substitute it as, which is equal to a into c into rho xy, that is 2 into minus 3 into 0.3 divided by 2 into 3. So, we can cut this and the answer is minus 0.3. That is the third one is the right answer, minus 0.3. Let y be a random variable with a probability density function. F of y is equal to beta raised to alpha divided by gamma alpha. E power minus beta y into y power alpha minus 1 if y greater than or equal to 0 and alpha greater than 0 and beta greater than 0. That is, the parameters are greater than 0 and y have non-negative values and 0 otherwise. If expectation of y is equal to 10 and variance of y is equal to 5, then we have to find out the beta and alpha values. So, from the density only we can see that it is a density for. So, from the density only we can simply write that expectation of y is equal to alpha by beta and variance of y will be equal to alpha by beta square. And its values are given 10 and is equal to 5. So, simply substituting in this only we will get, let this will be equation 1 and this be equation 2. So, from equation 1 we will get alpha is equal to 10 beta. We can substitute this in equation 2 and rewrite it as beta into 10 divided by beta square. So, we can cut it out. 10 by beta is equal to 5. So, 10 divided by 5 is equal to beta, which is equal to 2. So, we got beta value as 2. Now, we have to find out the alpha. That is, we have from equation 1, we have alpha by beta is equal to 10. So, alpha is equal to beta into 10, which will be equal to 2 into 10, that is 20. So, we can see that beta alpha is 20, 2. That is the right answer. Fourth option is the right answer. Let x have a symmetric density function f, symmetric about 15 and f be the corresponding distribution function. If probability of x less than or equal to 30 is equal to 0.8, then probability of 0 less than x less than or equal to 15 is. That is, we have to find out the probability of 0 less than x less than or equal to 15. So, here it is already given probability of x less than or equal to 30 is equal to 0.8 and the function is symmetric about 15. So, this we can write it as minus infinity to 30 f of x dx. So since it is symmetric about 15, we can write minus infinity to 15 f of x dx will be equal to 15 to infinity f of x dx. So since we have this result, we can split this minus infinity to 30 f of x dx. So simply we can rewrite this as 2 into 15 to 30 f of x dx is equal to 0.8. So integral 15 to 30 f of x dx is equal to 0.4. So since it is symmetric about 15, so we can rewrite or change the limit as from 15 to 30. That is, we have to get the 15 difference between the lower limit and upper limit. So this we can write it as 0 to 15 f of x dx is equal to 0.4. That is, we got it as probability of 0 less than x less than or equal to 15 is equal to 0.4. That is, third option is the right answer, 0.4.